I am Anil Kumar. Welcome to my series on IGCSE Math. Now, many of our subscribers and viewers are not very familiar with the terms upper and lower bound. So I thought I'll take up this video to bridge up the gap. So we'll try to understand the concept of upper and lower bound with the help of rounding principles, which we already know. So we'll actually take up the concept of rounding and then see how it is related with upper and lower bound. So here are two examples for us. First one is, what set of numbers round to the nearest 100 as 300? And the second question here is, what set of numbers round to nearest 1 as 6, right? Once we understand this link between rounding and the upper and lower bound, then we'll take up more examples which will be like this. We'll actually understand how to round to two significant figures. Now, significant figures are also the terms which are normally not used by many students, so that should help us to bridge the gap. And then we'll talk about one significant figure. Once you understand what is rounding to two significant figures, one significant figure is not difficult to understand. It's kind of similar thing, right? And then we'll take a practice exercise. And while we are working with the rounded figures this time, so we'll work with the rounded figures and we'll try to figure out what is the upper bound and lower bound for each number given, right? So that is the kind of work which we are going to do in this particular video. I hope that will give you very good insight to the topic of lower and upper bound, right? And after this, we will see in the next video how in calculations we could have minimum or maximum value from the lower and upper bound. And that's where it gets slightly more difficult and interesting. So let's begin with the very basic concept now. And let's try to understand how is this rounding related with the upper and lower bound. Okay. So as I was saying, what set of numbers round to the nearest 100 as 300? So on a number line, we have all the numbers, correct? We are talking about a number which is 300. Now what numbers will round to 300? Now from the rounding principles, we know that any number which is 50 plus and minus can be rounded to 300, right? So the lowest number which could round to 300 is 250, correct? So 250 rounds to 300. And on the upper hand, the limit is 349.999, like this, correct? So on the upper side, 349 point whatever will actually round to 300, right? So that is our rounding principle, correct? All these numbers round to 300. Now when we talk about upper and lower bound, then this lower limit 250 is termed as the lower bound. So this is the lower bound for us. Is it okay? So lower bound is kind of exactly same as what rounds to the number, the minimum number which rounds to the number. Perfect. As far as the upper bound is concerned, we kind of write it as 350, since, writing these nines means extremely close to 350. Perfect. So upper bound and lower bound, as you can see, are slightly different from our rounding principles, since the upper limit, which should have been 349.999, will actually be treated as 350 as the upper bound, right? So what we also do here is we use a nomenclature. This type of a bracket means included, right? So the lower bound is included, but the upper bound is not included. So we write a bracket like this. So this bracket means 350 not included. Do you understand? Not included. However, for our calculation purpose, we always will take 350 as the upper bound. Do you get the idea, right? So we understand it is not included, but 349.999 is very close to 350, so we treat this as upper bound. Does make sense to you? So that's how we'll be doing it, right? Next example here, we've just taken a smaller number this time, and the number is 6. Now this number 6, what numbers could round to 6? Well, numbers which we could round to 6 will be 5.5, right? So if I write 5.5, we know, including 5.5, it rounds to 6. On the other hand, we can go very close to 6.4999, correct? Something like this. So we say that the lower bound in this case is equal to 5.5 and the upper bound is 6.5. And we represent them like this on a number line. 5.5 is included, and that is with a bracket, which means normally not included. Does make sense to you, right? So in short, that is how it is. Now, let us also talk about how did we decide on adding or subtracting 50. Now, when we are saying in this particular case, we are rounding to hundreds, then what we normally do is we do 100 divided by 2. So which is equal to 50, right? Here we are rounding to ones place. This is ones place, right? So we divide 1 by 2 and we get 0.5. And that is how we decide on these numbers what numbers should be plus and minus. Do you see that? So these numbers should be plus and minus to get us the upper and the lower bound. Perfect. So I hope with this we can move on and take some examples. So one link between rounding and upper and lower bound I hope is absolutely clear. Let's move on and take some rounding numbers. So as an exercise, we'll see round to two significant figures. Now this term, two significant figures, written in short as 2SF, is also new for many of our subscribers, right? So let's try to understand. Now significant means most important, right? Think like this, most important. So when we say second most important, then in these numbers which I have given you, what is the second most important? Well, the second most important is from the left, the second one. Do you see that? So in this case, 0.4. In this case, this is the first one. That number is the second most important. In this case, 6 is second most important. 2 is second most important. In this case, this 2 is second most important. Does make sense to you? So rounding to significant figures, rounding to second two significant figures, that means we are rounding to this number, which is thousands, right? So what are we going to do? We are going to round this number, and since 7 is more than 5, we'll make it 99,000. Do you understand that? So that is what it will be. In this case, we are rounding to this number 4, looking at the number next to it on the right side, so that gives us 3.5. Correct? Here, we are rounding to 3, so that gives us 0.023, right? So we'll drop these numbers since 4 is less than 5. So we follow the normal rounding principles which we have learned. However, let's understand the significant figure number. It is taken from left, right? So most significant, most important, from the left side we go, right? So this is the first significant, second, third, fourth, fifth, like this. I hope the concept is clear. So taking that into consideration, you can route these to two significant numbers, and here we'll get 27. Here we get 120. In this case, that means to tens, right? And in this case, we are talking about tens and hundreds. So it is 0.12. So that is how you're going to round to two significant figures. I hope that is absolutely clear, right? So let's move on and take now one significant figure. Means most significant, right? Absolutely most significant. So most significant is the very first digit, right? When you see from the left side, you have to exclude these zeros. They are placeholders. So take these as placeholders, right? So these are the most significant digits. Rounding to this gives you 300. In this case, gives you 5,000. Here gives you the number as 0.003 because that is 5. this number becomes 20. So because this is 2, so it is 30, right? So one more, right? 2.9 gives you 3 and this gives you 0.2. So that is what is the meaning of one significant figure. Is that clear to you? Now I hope we have got the concept of upper and lower bounds. We have also understood how the rounding and upper lower bounds are related. We have also seen what is rounding to significant figures, right? And to decimal places, you know. We'll apply these principles to answer these 4 questions now. State the upper and lower bound of each of the following. The numbers are rounded as given in the bracket. So the first number is 5140 rounded to 3 significant places, right? That is 4. So you check from the left side. So that is your third significant place. Rounded to 2 significant places 74 and rounded to 1 significant place is 20. So that means 2, right? And this number is rounded to 1 decimal place, that is 0.6. You need to now write down the upper and lower bounds for these. Okay, so let's look into what kind of rounding was done. So when we say 3 significant places, we are counting first, second and third number, and that is in tens, right? So 10. So this place is the tens. We'll divide this by 2. So that means we have to do plus or minus 5, correct? To get a lower and upper bound. Is it okay? In the second case, rounding to 2 significant places 74. Now 4 happens to be in 1's place, right? So 1 divided by 2 will give us plus minus 0.5. Rounding to 1 significant place, that means we are looking at 2, right? So 2 is in 10's place, so it is 10 divided by 2. So we'll do plus minus 5 here, right? Half of 10. Rounding to 1 decimal place is 0.6, right? So it is 0.1, that is tenths, right? So divided by 2 gives us 0.05. So these are the numbers to work with to get our upper and lower bound, correct? So let's get the upper and the lower bounds for each one of them. I would like you to pause the video, answer your question, and then look into my suggestions, right? So let's write down the lower bound first. So when you do lower bound, you have to take away. So number has to be smaller, right? So in this case, smaller by 5. So it will be equal to 5135. And the upper bound is going to be a bigger number, bigger by 5. So it will be 5145, correct? That is how you're going to get it. Perfect. Now the next one here, we have to add and subtract 0.5. So we get 73. I mean, let me write lower bound first. Then I'll write 73.5. And the upper bound for us is 74.5. Perfect. Now here we have 20. And the number is rounded to 1 significant place. We'll round. So we'll add plus and minus 5. So the lower bound in this case is 15 and the upper bound is 25. Perfect. In this case now tell me, what is the lower bound and the upper bound? Round to 1 decimal place. So tenth has been divided by 2. 0.05 has to be added and subtracted. So we get 3.55 as the lower bound and 3.65 as the upper bound. Perfect. So I hope you understand now how to find upper bound and the lower bound in the given condition when we know that the numbers are approximate, they are rounded numbers, right? Now in the next video we will see what could be the maximum error or what could be the minimum value when we work with these rounded numbers. Perfect. So the question here is, find the maximum value the following could have. Given correct to 1 decimal place, x equals to this and y equals to 2.5, right? So we are given the value of x and y correct to 1 decimal place, right? So we have to find what is the possible maximum value for these calculations involved, right? So this is a very general question. It should help you to understand most of the concepts, right? So what we will do here is, working with these values, we know x is equal to 5.3, right? Now it is rounded to 1 decimal place. That means 1 divided by 5 is 0.05. So this number could have upper and lower bound of what? The lower bound for 5.3 could be 5.25, correct? And the upper bound will be 5.35. So that is the variation which x could have, right? So this is your lower bound, and that is your upper bound, right? Now let's also do for y, which is equal to 2.5. So for y, the values could be what? For y, the values could be, again, one decimal place. So if I add 0.5 to it, I get the upper bound 2.55 and the lower bound of 2.45, right? So that is the lower bound and this is the upper bound. So these are the values with which we can work to figure out the maximum possible value, correct? Now see, if the calculation involves addition of these two, how could I get the maximum? Well, to get the maximum, I have to take the maximum values, right? So I'll add the maximum values, which are 5.35, and to them I add 2.55, correct? And that will be our maximum value, right? So I'm going to use calculator for all these calculations. 5.35 plus 2.55 will give me 79 over 10 or 7.9. So 7.9 will be the maximum value. Does make sense, right? If I would have added any other combination, I will get lower than this. So maximum is when I take both upper bounds, right? So we take upper bounds for both. Does make sense, right? Now think about this. You want difference to be maximum. So how do you get difference to be maximum? Well, clearly, this number should be taken as the upper bound and the other number should be taken as lower bound. Then only the difference will be maximum. Does it make sense to you, right? So that is what it is. So in calculations, you have to apply the logic. So here, for x, it is 5.35 and we'll take away the lower bound value, which is 2.45, correct? That is going to give me the maximum of the difference, right? So it is 5.35 take away 2.45, and that gives you 2.9 as the value. Now when you multiply and you want maximum, then you have to take both upper bounds, correct? So when you multiply and you want maximum, you have to take upper bounds. But when you divide, for the numerator, you should take the upper bound, and for the denominator, you should take the lower bound. Does it make sense to you? So that is how we are going to figure out what could be the maximum value. So you can actually now pause the video, calculate these answers. So here it will be 5.35 times 2.55, and in this case it is going to be 5.35 divided by the lower limit of 2.45, correct? So let's calculate these answers. So we have 5.35 times 2.55, which is equal to, let's write decimal equivalent, which is equal to 13.6425, and the other case is 5.35 divided by 2.45, which gives us, we could also write in decimals, right? 107 over 49. Perfect. So that is how you're getting the maximum values. Now let's take a similar example, but this time we'll work with the minimum possible value, okay? So we have second example here, and in this particular example, we'll look into the minimum values. The question here is, find the minimum value the following could have. Given correct to one decimal place, x is equal to 6.4 and y equals to 2.6. Okay? So the process is going to be exactly same. Each number, x for example is 6.4, we'll figure out what is the upper bound and the lower bound. So to get the upper bound, we have to add 0.05, so we get 6.45, and to get the lower bound, we have to take away 0.05, so we get 6.35, correct? So that is what it is going to be. For y, the value is 2.6, and the two limits for the upper and the lower bounds are going to be 2.65 and 2.65. 5, right? So these are the two values. So these are the values which are for us the lower bound values and the upper bound values. Is that clear to you? Now we need minimum value. So if you need minimum value for addition, what should you do? Well, we should add their lower bound values, correct? If you need in subtraction minimum value, then x we have to look for lower bound, and for the y we have to look for the upper bound. Does it make sense to you? When you multiply, we should take both lower bounds for the minimum value, and when you divide, we have to take lower bound for the numerator and the upper bound for the denominator. So that is the basic with which we are going to work. And now let's figure out what the values are. You can actually pause the video and get the values. So let's add them up, which is 6.35 plus 2.55, correct? And let's use calculator. So we have 6.35 plus 2.55, which is equal to 8.9. The next value here is the difference. Lower bound for x is 6.35, and we have to take upper bound for y, which is 2.65. So we do 6.35, take away 2.65, which gives us 3.7. Now we have to multiply the two values which are lower bounds. We need minimum, right? So 6.35 times 2.55. So that is 6.35 times 2.55 is equal to, well, let's write like this, 6477 over 400, right? You could write in decimals or in fractions. Now in this case, we are looking for lower bound of x, which is 6.35, and the upper bound for y, which is 2.65. So 6.35 divided by 2.65 gives you the value of 127 divided by 53. Decimals, it is approximately 2.39, right? So that gives you a 2.4. So that gives you the minimum value. So I hope with this exercise you get the basic concept of how to get the minimum value or the maximum value when we are working with rounded numbers and considering lower and upper bound. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.